Welcome to this tutorial. In this tutorial we will calculate moisture ratio and we'll also calculate drying rate constant. Here you can see an Excel sheet which I have already prepared for this calculation. In the first column here is time, which is in minutes. We have continued this experiment for 180 minutes with 30 minutes interval. The next column is for initial moisture content weight basis, which we need for this calculation. We can easily calculate it by taking the initial weight and dry it overnight and weight it again. The weight difference will show the moisture content, as the dry matter will remain same and the moisture will evaporate from the sample. The difference will show the weight of the moisture. If we percent it, we will get value like this. Then we have to calculate moisture content in dry basis. We will convert this moisture content, which is in weight basis, into dry basis. A moisture content dry basis is nothing but the ratio of moisture to the dry matter. So as I have already said that the initial moisture content weight basis is in percentage, so we can get the dry matter weight simply by subtracting it from 100. Sorry, I have mistaken. So this is the initial moisture content which is in dry basis. Pasting this for all the cells, remaining cells. So this will remain same for all cell, as the initial moisture content is same for all the cell. Then here is the weight of empty tray which we use to put our sample, which is nothing but slices of potato. Then this is the weight of the sample with this tray. From the weight of tray plus sample and just the weight of the tray, we can calculate the sample weight just subtracting them. This is the sample weight, and copying and pasting this for all the cell, we will get the sample weight, which will decrease with time as the moisture of the sample, moisture from the sample will evaporate, and thus the weight will decrease. So for moisture, we have to use the initial moisture content weight basis. So if we multiply 110, which is the sample weight, with the initial moisture divided by 100, as it is in percentage, we will get the moisture content at 0 time or the initial time in 110 gram sample. But what we will do for the next cell in this column, we have to calculate in other way. Here this is the initial moisture and the moisture is decreasing. How much? If we subtract 110 and 74.6, this is the weight loss. So we have to subtract the difference of that which is lost by evaporating from the initial moisture, and thus we will get the moisture at after 30 minutes. Same for the rest of the cell. Then dry matter, now it's easy to calculate. Sample weight minus moisture will give the value for dry matter. Then the moisture at any time dry basis. I have already said that moisture content dry basis is nothing but the ratio of moisture and the trimeter. Just like it. Then in moisture ratio, I have already mentioned the formula. This is the ratio of moisture, dry basis, and the initial moisture. Here the numerator, which is the empty, will this, and the denominator is also this for the first column, and the numerator will change with time, which will be this, and so on, but the denominator, which is the initial moisture, will same. So we have to log this using dollar sign. So we will get 1. The maximum moisture ratio is 1, and it will decrease with time. So we have calculated the moisture ratio. Now we have to make a plot of time versus moisture ratio. I'm going to insert, then in charts I have selected scatter plot. We want this y-axis in logarithmic scale. Then I will add trend line, which will look like this, but we need this in exponential scale. Then it will look like this. We need the equation and the r square value. Now you can see that the value looks like this. So this 0.015 is the drying rate constant.